So we're going over section 2.1 today. That's it. You have homework for 2.1 due next Saturday at midnight on WebAssign. Let me know if you need help setting up your WebAssign account. And a reminder that you should start with the free trial just in case something happens this semester. So I've assigned 6 problems from 2.1. It's estimated to take 159 minutes, so about 3 hours of homework. And I think we're good to go. Any questions? Okay. So, this section is tangent lines and velocities. Let's start with, okay, a tangent line a tangent line to a curve at a point, a tangent line to a curve is a line that models the behavior of the curve right at that point. Okay, so we'll draw just kind of like classic curve is a circle. And I'll have a tangent line right here which touches the curve once and describes kind of, I can't see the bottom, describes the slope right at that point. Okay. Okay, so secant line.
What's at the bottom? I'm sorry.
Yeah.
Right at that, you know what?
Right at that point, or right at
Okay. That part.
Okay. I think we're good to go. Okay, so secant line is a line that intersects the curve more than once. So, also thanks for the assistance from the class. We'll draw a secant line. It's going to hit this circle twice. It should be kind of a straight line. Okay, so I've got steps. First, actually, another picture. So, does anyone experience a lag, or is it just me? Yeah, I'm sorry about the internet connection, but the recording should come out decent, like pretty easy to watch. Thank you for being patient. Okay, so let's draw X, Y, gonna go function. We'll just say like F. So, or okay. So let's talk about some points. We'll call this point P. Or actually, here, this is point P. Okay, so at point P, we'll draw a tangent line. So it's going to touch the curve once and describe what's going on, describe the slope of the curve right there. Let's try to go this. All right, we're going to work with secant lines, and we're going to have lines that go from P to some point Q. And then you're going to draw through those 2 points. Okay, so tangent line and secant line, and we're going to have secant lines that get closer and closer to P, and that way we're going to know from all of those secant lines what the tangent line is. Okay, so steps. Okay, to find slopes of tangent lines to a curve, let's see, we need to introduce everything. To find slopes of a tangent line, slopes of tangent lines, we let f be a function. And let's see, to a curve of a function, I'm sorry, I'm going to rewrite this. I have a better way to say it. To find steps to find slopes of tangent lines. I'm going to back up. I had a better intro. Okay, to find slopes of tangent lines. To a curve a specific kind of curve is a function at a point P. That's better. Okay, so the whole goal is finding the slope of the tangent line at a certain point. first step. You pick another point, we'll call it Q1. So Q sub 1. Okay. And it's close to P. Right. And then, make sure you guys can see this. That's good enough. Okay, so then you draw a line through the points P and Q1. So this is the line that goes through P, Q1. Compute the slope. Next step. You get another point, Q2, and it's closer to P. So pick another point. Q sub 2. Closer to P. And then compute the slope. Actually, we'll make that part of this. Of the line that goes through P and Q2. So that's of the helix. P, Q sub 2. Okay, then you record the slopes of the secant lines as these points Q get closer to P. So number 4. Oh, so Q1 is close to P and Q2 is closer, Q3 is even closer, and Q sub 4, 5, 6 on to Q sub n is getting closer and closer to P. So Q subscript lowercase n. The value they approach is the slope of the tangent line. And we're finally done with all the steps. So that's the last step. I have a I have like 2 examples for today. All right. I think we should just go through an example and then I'll check if you guys have questions. But if you ever have a question, just stop me. Even if you just can't read something, or if I make a mistake, let me know. So we'll introduce it here and we'll start a table of everything up here. All our scratch work up there. So example. F of x cubed. Compute the slope of the tangent line at the point 2, 8. Okay, so let's make space to do the scratch work. So first, your point P is 2, 8. This is your x. This is your y. Okay. Let's put in the slope. Slope is difference in y values over your difference in x values. Difference in y over. Okay, so I just put a little note. We're gonna do something like y2 minus y1 over x2 minus x1. So I'm gonna also do a sketch on the side. It's like maybe over here, graph. It's a cubic function. It kind of comes up, flattens out, and then up again. So up and over. And we're at the point 2, 8. So if you go over 2. Found it. Picture. Okay, so again, we're graphing. F of x equal to x cubed. So okay, f of 2 equals 8. That point's like right there. Let's label this part. I think that looks good. So now we want to find different points that get closer and closer to 8 from the right side and the left side. And we'll know after finding different slopes for those points, what the tangent line is. We're going to start from the left side. Okay, so what I have is x is going to approach 2, and then the subscript, or super, let's see, it was a negative up here. That's what I'm trying to say. So when you have this sign, it means you're approaching 2 from the left. I have quite a bit of stuff going on. So I've organized my scratch work so that I've got values for x. Actually, it's here. The output y. And we'll figure out what the different slopes are. The slope of the secant line. Okay. So again, P is the 0.28. These are going to be points for Q, where I'm going to pick values of Q to have an x value of 1, then we'll find out what the y value is. Then the x value gets closer to 2, so we'll put in 1, 1.5, 1.9, 1.99, actually I do want to make a space for this part too. And we'll make a guess, like just pick a number that we think is very, very close to 2. Okay, so we can do the first one by hand. So the first slope, let's actually, I think, fill out the y values. So this is y equals x cubed. 1 cubed is 1. So what do the numbers say? Okay. Yes, thanks for the help in the chat. So we're plugging in inputs of 1, 1.5, 1.9, 1.99. And then I think I'll show you the calculator I use, and we'll go ahead and work through getting the outputs. Okay, so here we go. I like this free online calculator called Desmos. It's the Desmos Scientific Calculator. Let's minimize me. Okay, so we're putting in numbers and cubing them. First number we're going to put in is 1, and you get out 1. I'm going to fill in my table, and we'll check back in a second what all the outputs were. So when you put in 1.5, the output is 3.375. Okay, so I'm recording this on the whiteboard. We'll get back to that in a sec. 1.9 cubed is 6.859. And then 1.99 cubed is 7.88. We'll do 7.881. And we're good. So we're going to skip this part and we'll get there soon. Now we need to do work on the side. So the first slope. Let's put it like this. We'll just call it scratch work. Okay, so we have the point 2, 8. What did I do? 2, 8. And the other point 1, 1. So the difference in the y values, a y value of 8 and a y value of 1, and then your difference in x values, 2 and 1. Okay, so 7 over 1 is 7. I think we're going to need a calculator now. Back to Desmos. Actually, here. And a fraction. In the numerator, we have difference in y values. The next output was 3.375. The difference in x values, x is going to stay 2, but the other x is 1.5. So that slope is 9.25. And we're filling in the table. Okay. This new point, we have an input of x equal to 1.9. The output for 1.9 is 6.859. So 11.41 is the next slope. And we're at 8 minus the last y value in our table, 7.881. Well, for difference in x values, to subtract 1.99. 11.9. Yeah, someone made the guess already. So just about to ask, what do you think this is? Someone said 12. You got this. We are going to still do all the work for going to the, on the left, going to 2 on the left side, but you've got the right answer. Okay, so I would like to do the table for x values that go to 2 on the right. It's going to be the same stuff, so I'm just going to like. So we're just going to start over with new info here. Okay, just giving everyone a chance to write down those last numbers we got. And x values are going to be all new. Y values we'll figure out. And we'll get new slopes. Okay, so this time you've got x equal to 2. And we're coming from the right side, so I picked, let's see. I started at 3. And then we're going to go to 2.5, and then 2.1, 2.01. Get like really close to 2. Okay. I'll just tell you what I got for my outputs. I double checked them. So first output, 3 cubed is 27. And then I got 15.625. $9.261. And then 8.121. Okay, so I'll do like, let's just do the work again. So for practice, we have our slopes. Y2 minus y1 x2 minus x1. We're going to have the point 2, 8 sit here every time. Actually, you know, I think I just had a habit of putting my other points in first. So there's 327 is 1 point. And we're approaching the point 2, 8. And then finding the slope of the line through those points. Okay. So I got negative 19 over over negative 1. Wait, hang on. Oh, it would be 19 over 1. Okay, 19. Okay, let's set up one more of the slopes. So Point 2, 8. Subtract another point, 15.625. 0.5, and then the output is up here. I'll tell you what I got. It's 15.25. And I'm just going to finish this. I did do the scratch work. Always double check things though. You can even find mistakes in solutions guides. Of course, I may make mistakes during class. Let's just try to fix them as a group. Okay, so I got 12.61. And the next output is 12.06. Oh, 12.1. Sorry. And someone's already mentioned that we're approaching 12. Okay, so we found the slope of the tangent line at the point 2, 8. And we found it to be 12. Okay, so we're going to play a little bit with limit notation, but next section is when we actually start to like go over limits. But what we're going to say is the limit is lim as p approaches q, or let's see, we have q approaching p. Q goes to b of the slope of the secant lines is equal to the slope of the tangent line. Again, we're getting into this next section. Let's go back to our problem. So back to this example. Now that you've got the slope, find the equation of the tangent line. So I like this form, y equals mx plus b. We know the slope and we have a 0.28, but you can also use, it's where you do y minus y1 equal to the slope times x minus x1. We'll give both a try. I'm going to start with this one, and we'll do that one. It's going to be the same answer. Okay. Okay, so slope is 12, and you're going to put in the 0.28, 2 for x, 8 for y. Okay, subtract 24 from each side, and you have negative 16 equal to b. And then you have to finish the problem and rewrite everything so that you have y equal to 12x minus 16. All right, so we're going to do y minus y1 equals m times x minus x. Let me try this again. Oh yeah. Yeah, my internet's pretty slow. So if you ever have internet issues, I totally understand. Let's go with y minus your y value 8. Put in the slope of 12. You have an x minus the x value was 2. Okay, so 12x minus 24. I want to isolate y, so add 8 to both sides. And y equals 12x minus 16. Same answer. Okay, so I'd say that we're halfway through 2.1. I have another part to introduce and another example to go over. And that's it. Any questions though? Any concerns? All right, definition for instantaneous velocity. Okay. Instantaneous velocity is the instant rate of change in a moving object's position. Let's see, what is the instantaneous rate of change? Okay, average velocity is the change in position divided by the change in time. Looks okay. Okay, and now I do an example. So here we go. A ball is thrown into the air with an initial velocity of 40 feet per second. Okay, so any more this problem. F of t equals -16 t squared plus 40t. We need something, there's something in the middle there that just, oh, is the height. Okay, is the height after t seconds. Okay, we have all the information for the problem. Now we need to find the instantaneous velocity at t equals 2, or at 2 seconds. that's our goal. We're going to do some scratch work. We have a note though. What we want. Is it okay for me? Let's pause. Finish velocity 40 feet per second. So up to here, I'm just going to erase. Actually, that's right. Okay. So I have a note that we let time intervals get smaller and smaller. You should, let's see, this the time intervals just get smaller. That's enough. Just shrink down the intervals and have them go approach 0. Okay, so I have a space for inputs and space for outputs, and then the space for the slopes or average velocities. But I'm also going to have a side where we have those lengths of the intervals. So a lot of scratch work. Okay, this is for elapsed time, which we're going to call h. To start, where we end, and the average velocity. Okay, so I made my intervals go from 2 to 3. And then 2 to 2.5. 2 to 2.1. 2 and over to 2.01. One more. We're going to have 2, 2.001. Okay, so the interval from 2 to 3. All right, the distance between 2 and 3 is 1. And the distance from 2 to 2.5, or the difference between 2.5 and 2, is 0.5. So I'm just finding the length of each interval. This interval has a length of 0.1. This interval goes from 2 to 2.01, so it's a distance of 0.01. And this one's 0.001. Okay. Scratch work. Average velocity. We're just going to put so this is supposed to be average velocity for the interval that goes from 2 to 3. Okay, these have f of 3 minus f of 2 divided by 3 minus 2. We need f of 3. Negative 16 times 3 squared, add 40 times 3. We also need f of 2, and we'll do this on the calculator. I just want to put all the scratch work down. So put 2 into the function, negative 16 times 2 squared. Add 40 times 2. And we'll work that out together. Okay. So let's put in the function like a skeleton. Put in this input, square it, add 40, and multiply by the same input. First input is 3. And I got negative 24 as an output. Okay, let's get this ready to go. Next input will be 2. And the output is 16. Okay, this here. So we've got, let's see, negative 24 minus 16. Over 1. It's negative 40. Let's work through one more, and then I'll just give you the rest of the numbers. So let's do the average velocity for the interval from 2 to 2.5. So it's f of 2.5 minus f of 2 over 2.5 minus 2. I'm just going to tell you what numbers I got. So for plugging in 2.5 to the function f, you get 0 out. We found this number, it was 16. And then this is a difference of 0.5 in the denominator. So negative 16 divided by 0.5 is equal to negative 32. Put it here. Okay, so I'm just going to jump into the answers for the rest of them. Next interval had an average velocity of negative 25.6. And then I got negative 24.16. And the last one is negative 24.016. Okay, so when we look at this side and we're looking at our average velocities going from 40 to 32, 25.6, 24.16, 24.016, we're approaching, someone want to guess? Down here to -24. Yes. Thank you. All right, so let's write that as, I have a nice way to summarize what we've done. So we let h be the elapsed time. We're done with scratch work stuff. Okay, again, we'll go over limits next class or tomorrow, but we'll have the limit as h goes to 0. The average velocities equals the instantaneous velocity, which is what we were looking for. I got -24. So that's the end of 2.1. And that's all I had planned for today. So I'm just going to erase. You have 2.1 homework. It's due Saturday the 6th. And I'm going to start making 2.2 homework soon. So please set up your WebAssign account and also feel free to ask questions. Stay if you have questions. Other than that, have a good day. Oh, we're done.